Unit 5 Friction, Module 2. Here we are going to learn friction in simple contact surfaces, friction of a body lying on an inclined plane, and later friction. Friction in simple contact surfaces. Consider a block. The block is having a self-weight W. The weight is balanced by the normal reaction NR. If the applied force is acting in this direction, the friction force will act in the opposite direction. Now consider this figure. A block is here, the self weight is acting downwards, so self weight is balanced by the normal reaction. So the applied force is this side, so the opposing force friction is acting in the opposite direction. So applied force is balanced by friction force. Numerical problem. A body of weight 100 Newton is placed on a rough horizontal plane and pushed by a force of 45 Newton as shown in figure A, B and C to just cause sliding over the horizontal plane. Determine the coefficient of friction in all the three cases. So block 1, consider case 1, that is a block with applied force. So block force, the applied force P is equal to 45 Newton and the weight of the block is 100 Newton. So draw the free body diagram. So the block is having a self weight of 100 Newton. The 100 Newton is balanced by normal reaction. The applied force P is acting in this direction, that is 45 Newton. So the applied force is balanced by the frictional force, that is Fm, or limiting friction. So apply the equilibrium condition, that is sigma h is equal to 0, sigma v is equal to 0. So condition of sigma h is equal to 0. So take all the horizontal forces, that is 45 minus Fm is equal to 0. Therefore Fm is equal to 45 Newton. And similarly sigma v that is Nr minus 100. Therefore Nr is equal to 100 Newton. So we know the coefficient of friction relation, that is mu is equal to F by Nr. Here F refers to limiting friction. So limiting friction is 45, Nr is a normal reaction 100. So coefficient of friction mu is equal to 0.45. Case 2. Case 2. Here a pulling force is in this direction, that is in an inclined manner, that is 45 Newton, which is an inclination of 25 degree. We have to resolve this into two forces as horizontal component and vertical component. So self weight is balanced by normal reaction. So pulling is taking place in this direction. Therefore your friction will act in the opposite direction. Apply the equilibrium condition. Sigma h is equal to 0, sigma v equal to 0. So vertically there are only two forces, therefore normal direction Nr is equal to 100, and there is one more vertical force. If we resolve here, there is 45 sine 25. On substituting and resolving the value, we can find the coefficient of friction mu as 0.503. In case 3, a same block is balanced by normal reaction. It has a pulling effect. Here it is a pushing effect. We have to resolve this into two components and apply equilibrium condition, that is sigma h is equal to 0, sigma v equal to 0. Write the equations and find the coefficient of friction, that is mu. The mu value is equal to 0.342. Friction on a body lying on an inclined plane. So now the block is placed on some inclination. So a block is kept on an inclination angle alpha. The block will be having a self weight. Since block is placed on an inclination, the block may tends to slide down. So the friction takes place in the opposite direction. A numerical problem. A block of weight 150 Newton is resting on a rough inclined plane as shown in figure. Block is tied up by a horizontal string which has a tension of 50 Newton. Find number 1 the frictional force of the block, number 2 normal reaction of the inclined plane, number 3 coefficient of friction between the surfaces of contact. So a block is here, the block is weighing 150 Newton, the block is kept on an inclination of 30 degree and the block is tied with a tension of 50 Newton. Since there is a tension, so the block may move in the direction towards the tension, so the friction will act in the opposite direction. We can see from here. You can see from here, or the in the absence of tension, the object may tend to slide down. Due to the sliding motion, the friction may take in the opposite direction. So, draw the free body diagram. That is, the self weight of the block is 150 Newton. Due to inclination, the 150 Newton is cut into two components, horizontal as well as vertical component. And that's the tension. So the tension is acting on based on some inclination of 30 degree. Again, this tension is split into two components, that is 50 cos 30 and 50 sin 30. Apply the equilibrium condition, that is sigma h is equal to 0, sigma v is equal to 0. Resolve all the horizontal forces and resolve all the vertical forces. By resolving the horizontal force, we may calculate the friction force, that is F is equal to 31.7 Newton. And resolving the vertical force, we can calculate the normal reaction as 154.9 Newton. Therefore, we know the relation, that is mu is equal to Fm by Nr. By substituting in the relation, we can find the mu, coefficient of friction, as 0.204. Next is a ladder friction. The ladder is a device used to climb on the wall. The ladder is made of wood or iron. There are two long pieces in the ladder to which many small cross pieces called rungs are connected at equal distance. If the ladder is uniform throughout its length, then the center of gravity of ladder will be at the middle point of it or midpoint of it. So this is a small representation of a ladder. So this is ground and this is wall. A ladder is kept here. So the ladder have an inclination in theta. So the ladder will have its own self weight W. If a man stands here, a man will have his weight, that is weight of the man. This will be the weight of the ladder. Weight of the ladder will act due to gravity, and this is weight of the man. So if a man climbs on a ladder, so here the object will tend to slide down. So normal reaction will take place here. Similarly, the ladder will touch at this point or slides down, and normal reaction acts in the opposite direction. Free body diagram for ladder. So this is a floor and wall, and ladder is placed here. Self weight of the ladder is W. So there are 2 points A and point B. When a man climbs, there will be a slide down motion. So that motion may be at point A, the motion may be towards forward. Therefore, it is balanced by the friction force FVA. So motion is here. It is balanced by friction force FA, and it touched at this region, so they will be having a normal reaction NA. It touched at this point, will be having a normal reaction NB. So the ladder may get the motion in the downward direction, so it will have a friction in the upward direction. So mu B is equal to FP by NP. Similarly, mu A is equal to FA divided by NA. A. A uniform ladder of weight 1000 Newton and of length 4 meter rests on a horizontal ground and leans against a smooth vertical wall. The ladder makes an angle of 60 degrees with the horizontal. When the man of weight 750 Newton stands on the ladder at a distance of 3 meter from the top of the ladder is at the point of sliding. Determine the coefficient of friction between the ladder and the floor. So consider the ladder. The ladder is placed in between wall and the floor. It is making an angle of inclination 60 degree. The total length of the ladder is 4 meter, and the weight of the ladder is 1000 Newton. So the weight acts at the center point. So a man is climbing on the ladder. The man weight is 750 Newton. He is standing at a distance of 3 meter from top. So from top 3 meter, a man is standing. His weight is 750 Newton. Now we have to resolve all the forces by applying the equilibrium condition, that is sigma V is equal to 0, sigma H is equal to 0 and moment is equal to 0. So ladder will have three equilibrium conditions, that is sigma H is equal to 0, sigma V equal to 0, sigma M is equal to 0. By resolving sigma V, we will get the normal reaction at Na is equal to 1750 Newton. Similarly, and resolving on the sigma H is equal to 0, there will be a unknowns. In order to find the unknowns, we are going to split this into three triangles, that is A, C, E. We are going to find a triangle that is A, C, E as one triangle. Next triangle with A, D, E, F as one triangle. Next, that is A, B, G as one triangle. So we are going to split this ladder into three segments of three triangles in order to take a moment. After finding the moment, you substitute in the relevant equation. You can find the normal reaction at point B, that is NB is equal to 396.9. So final expression mu is equal to, that is mu is equal to F by N, and friction is equal to mu into N. By substituting the known data, we can find the coefficient of friction as 0.226. Thank you.